Which one did you say, Hayden? 15. JFK, the U.S. president, had 3 brothers and 5 sisters. How many children did his parents have?
9.
Because he's the 9th. Yeah. How many brothers and sisters do you have? How many kids do your parents have?
4.
You know, think of it that way. At least in this situation. Generalize the given information and answer to part A, generalized. I guess maybe B plus S plus 1. How many brothers I have, how many sisters I have, plus myself, equals the total. Or you could say in words, his parents had one more child than he had brothers and sisters. You know, the brothers and sisters plus himself, which is 1. That's one way to do it. I don't know. Anybody write something different for letter B?
I wrote it, so it was added 10 to the brothers and then added them to the sister.
How so? I mean, what did you do?
Oh, I didn't know those.
You did numbers? Oh, so you did 1 plus 3 plus 5, is that what it is?
Yeah.
Yeah. When we generalize, we're using variables. It's a general relationship. It could be a relationship for anybody. So keep that in the back of your mind. We will be using variables more and more and more. And then you said 23. Oh. Choose all that apply. So you've got 164 over 4, 42 over 6. And 56 over 8. Okay. So when you add that all up, will it be a rational number? Because it can be written as a fraction, yes. Would it be a real number? Yes. You guys don't know about any numbers that are not real numbers yet. Someday you'll learn about numbers that are not real. But as far as you're concerned, real numbers are everything. They are decimal numbers, they are fractions, they're negative numbers, positive numbers, they're irrational numbers like the square root of 2 or pi. They're all real. The only things that are not real that we really ever get into in high school are what are called imaginary numbers. Once in a while, you guys, in math, if you get way down the line with questions, they might throw a question at you that has an I, a lowercase I, and that stands for an imaginary value. And you don't need to worry about that for a good long time. So, all numbers are real numbers. What about integers? Is that going to give you an integer? Yes? 56 divided by 8 is how much? 7. 42 divided by 6 is? 7. 164 divided by 4 is? 41. Yeah. Because 4 goes into 4 one time, and 4 goes into 16 4 times, or it goes into 160 40 times. So you can do that one in your head, maybe 41. So yeah, you add them up. That's an integer. Integers are 0, 1, 2, 3, 4, etc. -1, -2, -3. So integers are whole numbers and their opposites. That you have seen somewhere. So as we skip chapter 4, you may find that there are certain things in the review questions in particular that you say, hey, we didn't do that this year. And you're right, we would not have done that this year, like supplementary angles, because we skipped that in chapter 4. But what I'm doing is I'm skipping it because we lost time in spring. So we didn't get through everything that I wanted to get through. And we lost time this fall when we started late. So there are a lot of things that we might go through again this year, but I'm going to skip over because of time. And the reason is that there's a certain amount of stuff that I want to get you through. before you see algebra next fall. So that algebra isn't really, really challenging. You want to make it doable. So realize that. There'll be times with those review questions. And the way to deal with them, like if you didn't remember what supplementary was, when that question came up, what do?
Look it up in the glossary.
Go to the glossary, go to the back. Or go to the index and it'll tell you which page it's taught on. It's all in the back of the book. Or Google it. Whatever works for you. Any more questions on this? Yeah, ooh, careful, huh? Makes you feel like you're gonna fall off the back of the chair, but you won't. They just rock. You guys are sleepy this morning.
Yeah.
Why? You have lots of homework last night? You stayed up all night?
No, it's just when you don't have PE in the morning.
You don't have PE in the morning. That gets you going, huh?
You were just complaining about it yesterday, too.
So yesterday you're complaining because you had to do PE in the morning. Now this morning you're saying,
No, but it's a certain type of PE. Is it indoor or outdoor?
what do you like? You guys be like going outside?
Outside.
Now?
It depends. Not now. Not now.
No.
When it's like snowing.
That's nice though.
There's like a certain time when it's good.
Certain time when it's good, huh?
Hmm?
So it's the 11th. Armistice Day.
Yeah, I thought it was Veterans Day.
Yeah, the old name is Armistice Day, but it's Veterans Day. Same thing. They call it Armistice Day over in Europe. Here we call it Veterans Day. We've changed it to Veterans Day. I don't know when they changed that. But same thing. Gosh, I'd like to just go on for like a half an hour about it.
Not what?
Armistice Day. But I'll leave that up to Mrs. Andreessen. I hope she does today.
Probably won't. Yeah, I'll have it now.
I hope she does. I'll give an opportunity to look at it. The history is rather broad. It's worth reading about,
You can tell her.
regardless of what you think about everything that has to do with politics, government, the role in the world that different countries play. This is one to read the history about. It's pretty significant. It's a lot more significant than I think a lot of people realize. Probably more significant than I realize. But reading about it would probably be certainly not going to hurt anybody. Rules for adding. Is that right? It is. So we ought to be able to do this, right? Been doing it for a while, adding positive and negative numbers.
Mhm.
Yeah. But right away, they jump into something which is a little bit different. They don't jump into adding right away. They talk about absolute value. Now, I hope that you were able to take the time to write down each of the little blue and gold or blue and yellow boxes.
Yes.
Those are the different rules, different properties, and kind of gives you some insight to what is going to be in this particular lesson. But it starts out with absolute value. And absolute value, you know, you can have a big, long definition of it, but I think it's pretty straightforward if you just say that absolute value is the distance from zero on a number line. So it's the distance from zero, and it's on a number line. So a number and its opposite, like 4 and negative 4, have the same distance from zero. Therefore, they have the same absolute value. And when we write the absolute value of a number, we put it in these vertical bars like this. Those vertical bars are grouping symbols. Keep that in mind. They're like parentheses in a way. So if there were two numbers that were inside of here and they were being added, like 4 plus -5, you'd have to add them first. 4 plus -5 is equal to -1, and then that stays in the absolute value bar. And then the answer comes out. So how far is -1 away from 0?
1.
It's 1 unit. So when we express these numbers, we express them as a positive, because we talk about distances as positive numbers. We don't say, well, I went -11 miles today. Doesn't make sense. I went I went 11 miles that direction. So there's directions, but everything is measured as a positive length. So the absolute value of -4 then is how far it is from 0, which is 4 units. And then let's just do this. How far is 4 away from 0?
4.
It's also equal to 4. So we have two different problems that give us the same answer. And that's okay, that happens. That happens in math quite often. You can get the same answer several different ways. That works. But we don't ever take one problem and end up with several different possible answers. That doesn't work. Okay. So this applies to fractions, it applies to decimals. If you did this right here, the absolute value of -3/5, it's how far from 0? 3/5. So what they do is they use the number line. And then they say things like this. For example, if we took a -4, that could be represented like this. An arrow pointing backwards. And then if we took a +3, that would be an arrow pointing in the other direction. So if we had a -4 and a +3 that got put together, if you put those arrows on top of one another, we can look at the difference between the distances. So a +3 would look like this right here. So you have a -4 and then you have a +3. When you put them together, where do you end up? You end up at -1. This is what they call the slide model. You just slide up and down a number line. We did some of that last year. We did some of that in the last lesson. But there's another way we could look at this. There's a bunch of different ways we could look at this, really. But the next one is kind of like this. We have two numbers here. We have -4 and we have 3. And the absolute value of -4 is how much? It's 4. Yeah. And then the absolute value of 3 is how much?
3.
That's 3. Yeah, and we're not meaning to make this difficult. We're meaning to make it real straightforward. So another way of looking at the addition of a positive and a negative number like this would be to go and say, well, if I took the difference between the absolute values, which is 1, and then I look at the number that has more value, which is the -4, we use that sign with that difference to get our answer. Yeah, let me do it again. So we got all this stuff written here. We know that -4 plus 3 is -1, because we can slide and see that. But what we can do here is we can say, well, the -4 has an absolute value of 4. The 3 has an absolute value of 3. So what we do here is we subtract We subtract the absolute values. We find the difference between the absolute values. And then the answer will have the sign of the number that had the greater absolute value. This can help us do subtraction and addition with positive and negative numbers much more quickly. So let's just do another one that way. Let's take 14 plus a negative 7. How much is that?
7.
It's 7. So if we take the absolute value of 14, that's 14. If we take the absolute value of negative 7, that's 7. Subtract them, it's 7. And then the number that has the greater absolute value is positive, so my answer is positive. Yes.
So for the -1 plus 3 equals -1. So when you like crunch all that down to 4 minus 1 equals 1, does it like always work, if anything?
Where are we at? We just told me.
So
The black one?
yeah, then you go down and then where it's like 4 -1. Does that the subtract absolute values and the 2 dots, do those always work for anything?
Yeah. Yes, they do. 47 plus negative 40, okay? What's the difference between the two absolute values? 7. Which number has more absolute value?
Positive.
The positive, so your answer is positive. Let's flip it around. Negative 47 plus 40. Which one has more absolute value? The negative number does. So now the difference between 47 and 40 is 7, but the sign is negative. It always works.
So that's an easier way to do it.
What's that? Yeah, there's an absolute value of 0. What is it? It's 0. So now the difference between these two is 14, and there's more negatives. Yeah, absolute value of 0. The distance 0 is from 0? 0. This is very, very useful to get your work done more efficiently. Now the other one that's in this lesson that I think is really useful. I wish I had all the cards from the room, because it's one that I pointed out that was way off to the right. It was in yellow, and it read something like this here. A minus B is equal to A plus a negative B. That one is, that's a really good one. In here, oh my gosh, I thought it came up in this lesson. Maybe it came up in this. Oh, it's going to be in the next lesson. That's right. Because it's a subtraction one. I misspoke, I shouldn't have brought that up. So if you wrote it down, and you can leave it there, but I'm not gonna go into this one. This one's gonna come up when I see you guys on Friday. Well, the reason I write parentheses around this is because there's two symbols. It's just to make it easier to read, hopefully. But I'm sorry, I should not have jumped on that one. I think we'll stop with what I have there, and then I want to say something about rotations, going around a circle. So that's the other part of this lesson. Okay. So, like the clock. Which direction does the clock go when the hands are moving?
To the right.
And what is that called?
Clockwise.
That's clockwise, right? Okay. In math, we use the same words. We talk about a clockwise rotation, for example. If I was to draw a circle with a center, and then I had like the hand of a clock, so to speak, I drew a line in here. And then what I did is let's say I took my drawing or my protractor, and I said, well, I want to turn this into a 45-degree angle. Here we are. Here it is. This is 45 degrees. But I haven't said where I started from. If we say that we start at this point here, and then we moved over in this direction, this is counterclockwise. And counterclockwise in math is measured as a negative value. So this is a 45-degree angle, but if I think of it as a rotation, so there's an object here and it moves over to this point, we would call that negative 45 degrees. Counterclockwise give us negative numbers. Whereas if we do clockwise, those are positive. So if we put something else on here, let's say we started at this point here, and we moved this direction, that ends up, oh my gosh, what am I doing? I'm sorry. Counterclockwise. Now I gotta erase your memory. I put them up there backwards. I'm sorry. Counterclockwise is positive. Clockwise is negative. It's kind of like the opposite of what would make sense, because clocks go around. You think, well, then everything would be positive that direction, but it's not. I'm sorry. Clockwise is negative. So what I drew with a red here, this is going to be a negative value. And then what I drew in purple, that's going to be a positive 45 degrees. So, how...
What was it, negative going clockwise?
What, all that stuff that I erased off the board when you guys walked in? When you learn about that, then you'll understand why it's all negative. That's another 5 years or 4 years from now. It has to do with some things that they call trigonometry and how trigonometry gets displayed on a circle. But this 45 degrees, that amount, that number is called a magnitude. So if we started from this point here and we went around on a circle this far, we would say that this had a magnitude of 45 degrees. If we went this direction, we would say the magnitude was a negative, whatever the number of degrees are here. So how is that gonna get used in the questions that you have to work with today? It's gonna be like this. That's point A. And then point A gets rotated this direction 90 degrees. It's going to be a negative 90, right? So we're going to look at this as a negative 90, and it gets to that point. And then if it gets moved back, let's say it gets moved back 30 degrees. So now it comes back this direction 30 degrees. Its overall rotation is going to be the sum of these two. So we're adding positives and negatives. So in this case here, we would start with a negative 90 degrees, and then we would add 30 degrees. So what is the ending result?
Negative 60. Negative 60.
Negative 60 degrees.
Wait,
So this is all 90 in a negative direction, and then we add 30 back, and then this gets us to 60 degrees. So yes.
so
Your que-
this is another version of the down? Or is this only for
This,
angles?
well, the idea of adding positives and negatives, what we're saying here is that it's not just limited to segments, for example. Like if we added 10, and then we added a negative 6, and put that together, and we ended up at 4. This would be showing segment addition. This is angle addition. So it's just another way of showing that we can put together positive and negative values. And it's another way that in your future, you're going to be seeing in geometry rotations which involve positive and negative magnitudes. So with this here, the end result is a magnitude of negative 60 degrees. So the magnitude ends up being the number, and the negative or positive tells us the direction. So in this case here, going counterclockwise is a positive 45. This would be a magnitude of 45 and a positive direction or counterclockwise direction. So at the end of this lesson here, page 290.
Well, this
think it's one of the review problems. Is that right? Yeah. Number 36, actually. You're gonna need your graphing calculator for that. So if you don't finish, make sure you take it with you. If you're using your calculators and it starts to get hard to read the numbers, you can use the second button and then the up arrow, second up, over and over, or second down, and you can make your screen lighter and darker. So as your batteries slowly die, your screen slowly is harder to read, and you can use that second up option. And second down. And then you'll also know your batteries are getting close to close.